All right, everyone, we are live. Hello, science fans. Happy Wednesday. My name's Gina, and I'm the outreach manager for NOVA. Thank you for joining us today for our third and final field trip in our series celebrating Earth Day and Environmental Education Month. We've really enjoyed hosting this series for you all the last 3 weeks. We've been able to visit some remarkable locations and learn from some incredible scientists at the top of their fields. And all of that is thanks to you. So thank you, the students, the educators, the families that have all tuned in every week. Thank you for watching. Thank you for asking your questions. And thank you for coming back each week. So I'm so excited to introduce you to today's speaker, Melisa Diaz. Melisa is a PhD student at Ohio State University. She's studying the geochemistry of ice-free areas in the trans-Antarctic mountains. And she became involved in polar research after doing fieldwork in Greenland in 2014, and since then has spent 2 field seasons in Antarctica at both large stations and smaller camps. She's one of the few Latinas to visit both the polar regions and is the former president and current outreach coordinator of the Ohio State chapter of SACNAS, the Society for the Advancement of Chicano Hispanics and Native Americans in Science. I hope that you have your parka, your hat, and some gloves close by, because today we are going to an adventure to some pretty spectacular places on our southernmost continent. So if you have any questions for Melisa throughout her presentation, please ask them. You can drop them in the comments on both Facebook or YouTube. We're looking at them both, and we'll try to get to as many as possible during our time together. So without further ado, Melisa, I'm going to ask you to take it away.
Thanks, Gina. So thanks again, everyone listening and watching. I am going to share my screen and hope for the best. Did this come through okay?
Yes, looks perfect.
Great. So hi, I can't see everyone, but hopefully you can still see me. Like Gina said, my name's Melisa. I am a PhD candidate and National Science Foundation Graduate Research Fellow with the Ohio State University in the Bird, Polar, and Climate Research Center. So I'll be talking a little bit about what I do as a PhD student and the work that I've done in Antarctica. You'll see that I have a whole bunch of names at the bottom of this slide over here. So a lot of the work that I do in Antarctica for my PhD comes from a grant, and these are the PIs on that grant. So it's Dr. Adams, Hogg, Fuhrer, Wall, Lyons. These are people that you'll probably see throughout this talk. Shameless plug, if you want to see more pretty pictures about Antarctica and keep up with what I'm doing as I continue through my career in academia, I have a Twitter, it's EarthMad. And then if you have any further questions, my email's there as well. So my family is really important to me, and I wanted to just give you a little bit of an introduction on who I am. So my dad is from the Dominican Republic. He was born and raised there, and he still currently lives there. This is my mom, and if she's watching this, she's probably gonna laugh with her nice 80s hair. And my mom was born in New York, and she's half Puerto Rican. So these are my siblings. My mom is holding my oldest sister in her picture. This is my other sister and my little brother. And this wild child in the very long blue shirt is me. I grew up in Massachusetts, though I was born in New York, like my mom and my other sister. And I included the flags for those states in case you're not aware. And the true flag for Boston, so the Boston Red Sox logo right there. And I grew up in a small town in Massachusetts. It's called Maynard. And most of my time was spent playing outside. I consider myself a river or a swamp kid. I would come home every day really dirty from just playing in the river. And you can see that river in the background of my picture. And that's the Assabet River for anyone who wants to look it up or is familiar with it. So I really like playing outside. I took a couple of earth and environmental science classes when I was in high school, and I was sold. This is what I wanted to do. And I was told by guidance counselors and those around me that if I wanted to do this as a job, that I would need to go to college. So I went to the University of Rochester. Now, when I went to visit University of Rochester, It was a beautiful May day. The trees where the cherry blossom trees were blooming and the grass was lush and green, and it was the prettiest campus I've ever seen. And I think it still is the prettiest campus, but this is much more representative of what it looks like the majority of the time you're a student there. So I spent a lot of time in the snow at Rochester, and I grew up in Massachusetts having played in snow a lot, but definitely not to the degree that you have in upstate New York. So I was a low income student and I had work study. So I did some research in neuroscience for a little while. Definitely wasn't my field, but my academic advisor, he offered a position in his lab. He said, hey, you have work study. Why don't you actually work in my lab? It's an ice cores lab. So through that experience, I actually got the opportunity to work with ice and work with gases and take a trip up to Greenland and help them with their field work the summer after I graduated. And that for me was a really transformative experience, realizing that I love these cold places and I wanted to pursue a career in that, and that meant going to graduate school. So as a graduate student, I work primarily now in Antarctica. So if you've been following the Polar series with NOVA, you've probably seen a similar image numerous times. But here's Antarctica if you're unfamiliar. Just to point out a few things, South Pole is in the middle, and we're looking at the globe from the bottom up. So if South Pole is here in the middle, everywhere from it is actually north, which is sort of a weird thing to wrap your head around. So when I talk about north, it's actually in almost any direction. McMurdo Station, which is the large US base, is located down here on Ross Island, and that's a volcanic island. And I actually work in the 2% of Antarctica that is ice-free. So you can see from this picture that Antarctica is mostly covered by white, that's snow and ice. But there's these really small brown patches, and those are areas that don't have ice. The main ones that I'll be talking about are the McMurdo Dry Valleys, that's that bigger gray patch here, and then some peaks of the Transantarctic Mountains. So the Transantarctic Mountains are it's this really long mountain chain here that traverses the continent and separates East Antarctica on your right from West Antarctica over on your left. So these are the places that I've been in Antarctica. Taylor and Mears Valley are both in the McMurdo Dry Valleys, and the Shackleton Glacier is the main site for my dissertation work. Now, these are two different types of ice-free area, and hopefully you can see this video. And I apologize, it's a little shaky. It's from a helicopter. So these are the McMurdo Dry Valleys, and I'm actually in Taylor Valley in this video. You can see that there's a lake over on the left-hand side. That's that flat white area. Over in the background on the left, that's Commonwealth Glaciers. That's a glacier that's coming down from the mountains and spilling out into the valley. And these valleys are primarily ice-free because of that mountain chain. The mountain chain helps stop ice from flowing into this valley. These are also polar deserts. There's very little precipitation, and the temperatures are primarily below freezing the majority of the year. There's a few days or a few weeks in the summer, and you can see in this picture where there's enough, or temperatures are high enough to actually start melting some of that ice. So with that little precipitation, even if it does fall, the air is really dry and it's really windy there. So all of that precipitation is either evaporated or sublimated. So this keeps the dry valleys dry. Now, the other type of ice-free area that I work in are these mountain peaks. So now you're looking at a glacier merging in with the ice shelf here. And there are these really tall mountains that actually poke above the ice. And that's really what we were studying when we were at Shackleton Glacier. So this is another video here. And again, we'll give it a minute to see if it buffers a little bit better. So in this video, I'm actually on the glacier. We're in a plane, sort of like the one that you see outside of this window. And there are these really tall mountain peaks on either side of the glacier. And that's part of the Transantarctic Mountains. So we wanted to go and look at these soils and understand the life that's in these soils and how that life has lived throughout potentially millions of years and how it's adapted to living in Antarctica. just to give you an idea of what these soils actually look like, this is the team that I mentioned earlier on that first slide. And this is what you see on these mountain peaks. So Antarctica doesn't have large woody vegetation right now. It did in the past. The soils are very salty. It's really rocky. It's not like the soils that you might find out in your backyard. There's really no water. You can see these small snow patches, but those don't end up melting. They usually just end up evaporating or sublimating. So that's from solid to gas, if just to recall from your classes. But in these soils, if you look closely enough, you can actually find life. So over on the left-hand side, that grassy looking picture, that's some lichen, which we find here in the States too. You have columbella, so those are springtails. Again, you can find them in your backyard. And I'm sure most of you have seen these little red mites. We also have nematode worms and tardigrades, also known as water bears. So these are the tops of the food chain in these soils. And with the exception of maybe these guys here, you really need a microscope to see them. So there's no penguins walking around these soils, there's no birds. This is really what you think of when you talk about life in Antarctica. But again, these soils are really salty and they don't have water. So our team is trying to understand how these organisms persist and how they thrive in some cases in Antarctica in these really inhospitable soils. And then what factors influence where we find them and where we don't. And I'm a geochemist. I study the chemistry of Earth. So I focus mainly on these abiotic factors. In this case, that's something like geography and soil chemistry. So when you think about answering these questions, I've been talking a lot about Shackleton Glacier, but I just wanted to go through why we chose this area, considering I show you this large mountain chain in Antarctica. And a lot of it has to do with how special this area is. So on this side, on this picture over on the left, this is Shackleton Glacier. And north in this picture is actually pointing down. Again, remember, it's the bottom of the world, so north is kind of strange. The Ross Ice Shelf, so closer to McMurdo Station, that big base, is over on the bottom of the picture. And the polar plateau, so think South Pole, is over at the top of this little map. And the glacier flows from the polar plateau down to the Ross Ice Shelf. And all these locations that I've labeled in purple, those are the sites that we visited. So this is where the glacier is right now, but 20,000 years ago, during the last glacial maximum, this glacier was much thicker than it is today. And what that means is that some of the ice-free areas that we see right now were probably covered by ice during this period. And I have this picture down here to show that. So on the x-axis, we're looking at distance from the Ross Ice Shelf. So this being the Ross Ice Shelf 0 point, and then we're moving up further towards the polar plateau. So that's this way. And then we're also looking at elevation. These little triangles represent the mountain peaks that you see on the map. So if you look at this blue line, that's where we see the modern ice surface. That's what's today. And the dotted black line above it is the last glacial maximum ice surface. So if you maybe look at Mount Heakin, which is about 70 kilometers in, if we pick sort of this random point above the blue line, that's saying that that point right now is ice-free. It's exposed to the surface, but it's below that dotted line. So 20,000 years ago, it was probably covered by ice. So that's what I mean by these glacial histories. Some of these places, like Roberts Massif, way at the far end at 120 kilometers inland, it's probably been ice-free for a very long time. But some of those soils that are below that dotted line are more recently exposed. How does that relate to where we find biology? We also have multiple sites at the same elevations and latitudes. If you're thinking about the scientific method, you have to have a control, you have to have replicates. And this is a way to do it naturally. So you can see Bennett Platform and Mount Augustana are at the same latitude, they're at the same side. So we can make some basic assumptions and say maybe the same processes are happening there. If there's an effect with latitude, we wouldn't see it between those two sites. These are simple ecosystems. when I'm showing you those nematode worms or those columbella, these tiny, tiny organisms, that's the top of the food chain. It makes it much easier for us to look at these systems and understand how they function. And then lastly, it's one of the least human modified environments on Earth. In fact, there are probably places that we went on the Shackleton Glacier that nobody's ever walked before. So that means that we don't have other variables that we have to worry about that humans might have modified. So how do we actually do the science? This is a picture of us coming off of the plane entering Shackleton Glacier. And again, this camp is actually on the glacier. So the snow and the ice that we're walking on is the Shackleton Glacier. You can see Tent City, we call it, over on the left-hand side. And this tube yellow building was where we ate, that's our galley. And then we have a recreation hut, and that's that little pink building over here. We primarily stay in tents. We were based out of Shackleton Glacier Camp, meaning that every day I returned home to this. This is my tent. And we took a helicopter to each of our locations. And our helicopter pilots were great. These are two of them right there. And this is Dr. Hogg, Dr. Fear, and Dr. Wall. And the short one in the middle is me. If you can hopefully see this video as well, this is us flying in the helicopter up the Shackleton Glacier heading to one of our campsites. So the white that you see in sort of that middle background area, that's the Shackleton Glacier. The gray that you see between where you are right now in that area, that's a moraine, so sediment that's pushed by the glacier. And you can see these mountain peaks above it. And these are where we're headed. So once we get there, what do? Well, we collect a lot of soil. So we have these little plastic scoops, and we're collecting the surface of the soil at all of those locations that I mentioned. And in total, we had about 230 samples. Some locations, we also collected depth profiles. So this is me and our mountaineer, Jeff, collecting just a shallow depth profile. And those are a separate subset of samples for my individual research. And we collected more soils, but it was great because our view was always fantastic. And I would argue that Shackleton Glacier is one of the most beautiful places in the world. And we were so grateful to have the opportunity to get there. So after we get back home, what do we do with these samples? Well, as I mentioned earlier, a lot of the members on our team are biologists, ecologists, and I'm more on the geochemistry side. So you have to start with a general idea of what your samples have in them and what these samples can tell you in terms of a story. So this is that same picture of Shackleton Glacier that I showed earlier, but now it's just flipped to the side. So instead of north being down, north is now pointing towards the left. So the Ross Ice Shelf is now towards the left, and the polar plateau, where the South Pole is over on the right-hand side. Now, we're looking at the frequency of samples with detectable biomass looking at nucleic acids. And I know that sounds fancy, but really what we're trying to say is, if we look at this soil, does it have signs of life or does it not? And we have this transect, or this trend, where as we move further inland, further towards the South Pole, we actually have less and less biomass. So by the Ross Ice Shelf, most of our pie charts are blue, and then as you move inland, most of the pie charts are now leaning towards that orange. And just to give you an idea of how incredible this finding really is, if you were to go outside in your backyard and collect soil from just your garden, you would find that there are billions of nucleic acids. But here, the same idea, same surface of the soil, we couldn't find any at some of these locations. And really what my job is to help inform why. So we have these 230 samples, and we brought them back to Ohio State. And the first step in what I do is to dry these soils out. Even though most of them are dry, you have to be sure. And then we mix that with water. It's called leaching, and we measure the water. So if there's any salts that are dissolved by that water, we can measure it. And that's what's shown in the picture on the bottom. And just like the biologists, we can create similar plots with similar trends. So now we're still looking at that distance from the coast, moving inland, but on the y-axis, we're looking at total salts. And on this one on the bottom, we're looking at elevation. And just like the biology, we can see that there's this trend where it's related to distance from the coast, and in our case, also elevation. So as you move inland, you're actually getting saltier in terms of the salts that are dissolved in that water that we leached. And same thing too with elevation. As we move up in elevation, so higher up on those mountain peaks, we are increasing our salt concentration. So this is something that we can do then and say, okay, we see these general trends. What's interesting about these? Where can we go from there? And that's really what I focus on as a PhD student. So this is 70% of my job, to look at these soils, to look at the chemistry and try and understand what we're seeing and how that might relate to what the biologists are seeing as well. The other 30% of my job, in case you're wondering why I showed those pictures in the beginning, is related to diversity and inclusion. Again, I'm a Latina scientist studying Antarctic geochemistry. It's something that I find really important. So this is a series of pie charts from the American Geosciences Institute. And we're looking at the race and ethnicity of graduating students with bachelor's degrees, master's degrees, and PhDs. Overall, you can see that the majority of students graduating are Caucasian. And I'm going to draw your attention to this red part of the pie chart. And this is your underrepresented minorities. And what that means is your African-American students, your Black students, your Latinx or Hispanic students. So your students generally of color or students that are racial minorities in this country. So at the bachelor level, bachelor degree level, it's about 8% of those students are underrepresented minorities. It actually goes up a little bit, which is pretty cool, to 12% at the master's level. But you can see that at the PhD level, where's that red piece of the pie chart? It's gone. And this isn't something new. In fact, it's now something that a lot of news outlets are picking up on, and there's a lot of studies about this. How can we fix the diversity in geosciences? This is an EOS, increasing diversity in the geosciences. Scientific American, why don't the geosciences have more diversity? And then in NOVA as well, moving the needle on diversity in the geosciences. And especially these last two articles, they point out something that I think is really important. So it says here that exposure to geology is important, and that that lack of significant childhood experiences with outdoor spaces could be why we don't have diversity in geosciences. I was very fortunate that I grew up in an area that had a backyard, and I played in the river, and I loved that. I also was fortunate that my high school had some geoscience courses that I took. But how can we help students who maybe don't have access to those things? One of them is, for me, I am involved in SACNIS. And again, it's a really long acronym that Gina did a great job with earlier, but it's the Society for the Advancement of Chicano/Hispanics and Native Americans in Science. And really what that means is the group is geared towards fostering and promoting diversity in all fields of science. So I'm involved in the Ohio State chapter. This is all of us at the recent conference in Hawaii. And we invite speakers and we interact with high school students to help increase diversity in STEM. And the last thing that I'll mention is that I'm also really involved in education and outreach at Bird Polar. So hopefully this works. I'm gonna try and hop on the web. And we have a series of education and teaching activities and lessons. So if you go on just bird.osu.edu and click on educational activities and lessons, there's a lot of content here. And some of the fun stuff that I've been working on, I'll click on these coloring pages. So we have all these coloring pages that are free for download, free for anybody to use. Here's mine, which was pretty awesome to help make. And we also have these new virtual reality tours. So again, even if you don't have access to abundant outdoor spaces, and especially now with quarantines, you can still experience some of these fieldwork expeditions that we've been on. So the one that I've been involved with is here in the McMurdo Dry Valleys, and you can click on this virtual tour, and I won't go through it because it'll take a while, but that's me in the blue sunglasses. And you can actually click around and see what Antarctica looks like and see the field work that we do. So we've made a few videos, and I've done a few, but that's sort of my contribution is, I can't really change a lot of things from home, but we can at least increase exposure. So that's all I have.
Great. Thanks, Melissa. We have a bunch of questions for you.
Okay.
So
great.
let's start off. We have a question from YouTube. It's a student from Brown Elementary, and he or she wants to know, what is the coldest temperature that you've ever been in?
So the coldest temperature was when I was in Greenland, and that was -56.
Oh gosh, what does that, like, how do you prepare for that? What does that feel like on your body?
So I thought that, going to upstate New York and growing up in Massachusetts would prepare me. And I honestly don't think that there's a way to prepare. We stepped off the plane, and you can just feel your breath just leave your body, and all the moisture, it just leave your body because it's so cold and dry.
Oh God. And you're like, yeah, let's go. Let's keep doing this.
Well, they give you a lot of candy to help thicken you up so that you stay warm. So
do you get to go on like a pre-polar like candy binge before you go, or like?
Oh, totally. Yeah. I brought, so it was we went right after Easter, and my mom sent me pounds of jelly beans. I think I took 6 pounds of jelly beans with me to Greenland, and tons of chocolate. It's great.
Is that your candy of choice, jelly beans?
It's my Easter candy of choice.
I see. I see. You can't, I mean, I guess you could get jelly beans all year round. That's true.
Yeah.
So in a similar vein, we have another question from a student from Brown Elementary that wants to know, why are the polar regions always so cold?
A lot of that that's a much more complicated question than I think that's a complicated question. But in short, a lot of it has to do with where they are. So the polar regions during certain times of the year don't actually get any sunlight because the Earth is tilted. So when it's tilted away, the North Pole doesn't get any sunlight. And then when the Earth moves around the sun, now the South Pole is tilted the other way. It has a lot to do with ocean currents as well. So the North Pole is a little bit warmer because we have a lot of land mass up there. We also have that strong jet stream current from not jet stream, sorry, the thermohaline current coming up towards the North Pole that brings warm water. Antarctica is like really special in the way that it's cold. So it actually has what's called a circumpolar current. So it has these really strong winds that circle Antarctica and keep any warm land masses really from getting to Antarctica. And yeah, I can keep going. There's like tons of reasons, but a lot of it has to do with geography and atmospheric and oceanic circulation.
Cool. We have a question from Dr. Williams James Smith Jr. on Facebook, who would like to know, what are your degrees in, and where did you do your PhD, and how did that lead you to this kind of work in a place where most people could never reach?
Okay, big question.
Yeah, we're coming in with the hard hitters.
That's great.
We have a very engaged audience.
Yeah, well, so I went to the University of Rochester for my undergraduate degree. So that's in upstate New York on Lake Ontario. And I have a degree in Earth and Environmental Sciences. That's a bachelor's degree. I have with an emphasis on atmospheric chemistry. And then I have 2 minors. One of them is in chemistry, and the other one is in Japanese, which hasn't proved useful in my studies yet, but I'm hoping that it will.
Yeah.
I went to The Ohio State University for my master's. And for that, I did dust work, and that's in geochemistry or earth science. I'm actually not sure what it says on my diploma now that I think about it. And then I'm also at Ohio State for my PhD. So it's going to be in earth science, geochemistry, whatever they put on there. And how did I get there? Well, a lot of that has to do with serendipity, being in the right place at the right time, and having mentors and people that care about you to help you out. So I wasn't initially the best student as an undergrad, but I had people that cared about me and said, hey, why don't you try this out? And they gave me a chance, and I think they thought I did a good job, and I really liked it, which I think is more important. So here I am.
Here you are.
Yeah.
We have a question from Derek Hoke from YouTube, who has a question about the microorganisms. So are many of these microorganism remnants of the distant past, or are they recently introduced?
Yeah, so there's a really interesting paper that hopefully is going to come out soon about this. So some of them are and some of them aren't. These organisms are small enough that they can be blown in by wind. And there's actually a bonus slide that I had on my PowerPoint that I won't bore you with right now. But if you actually look at the phylogeny of these organisms, so their genetics, some of them show that they have been there since Gondwana. So one of those big supercontinent periods, several million years ago. And they have actually evolved in place. Meanwhile, some of these other organisms have been blown in by wind or, during different periods in time. So the question is both.
Yeah, because when we think about the answer, sorry. No, that's fine. So when you think about the water bears, we can find them here, or we can find them, all the way in Antarctica. Are they the same water bear? Are they a little different?
I'm not exactly sure on that one. I'm not the best biologist.
Sure.
But I think that it's probably a little bit of both, being introduced in multiple different ways. But like the Columbella, for example, there's an article from our group that actually just came out in Scientific American that shows that some of these have actually just evolved in place over the last several million years. Okay. Meanwhile, others and diatoms, for example, are windblown from the ocean.
Mm-hmm. And in a similar question, in a different direction, Sean Fontaine from Facebook wants to know, does any of this research apply to the search for possible life on Mars?
So I'm always a little cautious to make the direct link there. But off the record, yeah, totally, absolutely. I think that when you think of Antarctica and I show you that picture of us walking on that surface, I mean, I feel like I could find that image on some Mars rover, footage. And there's so many parallels, and the dry valleys are often used as an analog environment. But really the goal of our project is to understand first how life exists and persists here on Earth. So how did these organisms survive through all of these really difficult times, through changes in the glacial height, through extreme temperatures and these really high salt concentrations. And I think that while answering these astrobiology questions isn't really a goal of this project, it definitely is a building block to keep moving in that step. Again, understanding how things work here before we can start extrapolating other places.
Yeah, that makes sense. We've got a bunch more questions coming in for you. So
okay.
And folks, if you still have more questions, we're still taking them. So drop them in the chat boxes, YouTube or Facebook, and we will try to get to as many as we can. So I have a question from Jessica Albertesh. I'm so sorry if I ruined your name, Jessica. How do you feel climate change will affect the microbes?
So that's something that we're still trying to figure out. So that picture of the nematode worm, there's several species of nematode worms, and Diana Wall and Byron Adams, they're, I hope they don't hear me butcher this, nematologists. And some of these organisms actually really like the salty, dry environment of Antarctica. So like Scott Nemma is one of these nematodes, and it likes being dry and it likes being salty. So when you actually put it in a wet environment, it doesn't like that very much. But then there are other organisms that are super happy and they start to really grow and reproduce because they love being in fresh water or in these other systems. So in a lot of cases, really what we'll see is if these glaciers start to melt further and we start to change the climate of Antarctica, there are some species that are going to be really happy, and there are others that aren't, and they're probably going to be, there's going to be competition and they're going to be outcompeted.
I've got another question from Genevieve de Meseret. Do you have to take precautionary measures in case there are any ancient microbes in the Antarctic soil that could be viable?
We were not super concerned about that. The idea being that if these are exposed to the surface, that they should be at least somewhat modern, but it is something to consider. I know that when we were digging into these subglacial lakes, so you think of, the 2 kilometers of ice in Antarctica, there's actually lakes that exist beneath that ice. And I know that that was a concern, is to not only protect these pristine environments that maybe haven't been exposed for a long time, but also to protect ourselves because we don't really know what's in there. But for our work, we're not super concerned about it just because we're collecting things on the surface.
Yeah, that makes sense. Noah Roberts from Facebook says, "You did great, Melissa." And what's the most unexpected find or data that you've come across in Antarctica so far?
I'd say the most unexpected find would be that pie chart that I sent. So to find that there are some of these soils that we tried, that our colleagues tried everything that they could, and they couldn't find any signs of life. I think for me, the like most incredible thing from like my research is I gave a talk about this. It's actually it's on the bird website somewhere. That the Shackleton Glacier environment is much more dynamic than I thought it was. So we have these satellite images and we use them to help plan our field season. And we found some old papers from, old 1996. We found a paper from 1996 that had some pictures of the same area. And what we found is between my pictures and the satellite pictures, there's actually melt that's happening in some of these valleys that we visited, where there was only maybe 1 or 2 small lakes. Now it's like one huge lake. And for me, that's the most surprising thing. And in that video that I showed when we were flying on the helicopter, you maybe noticed that on that moraine where the sediment was, there's actually a little river, and it's draining onto the ice sheet or onto the glacier. And there's like a small pool of water on there. And that was something that I really wasn't expecting to find. And you can go back and look at the succession of these satellite images and see that it's actually a really dynamic hydrologic system. That was surprising.
That's such a cool discovery. I mean, how do you feel? I mean, you've spent 2 seasons in Antarctica, you've been to Greenland. Like, how does it feel as a scientist to like just constantly kind of, you think you've seen, an environment, or you've seen, seen what not that you've seen it all, but then you have an experience like this that's still like, excites you and inspires you, and like, how does it feel to come across moments like that?
I think it's just really fun. It's one of the reasons why I like doing this, to not to necessarily be the person that's discovering everything, but just to be curious and say, oh, that's interesting, I wonder why. And I love what I do because I can ask why. So it's fun to be there. And even going to these places in the dry valleys, you pick up on different things or you notice different things. And every time you're learning something new. And I think that's why I love it, because it's really fun.
That kind of leads me to another question we have from YouTube, from Savannah Hollenbaugh, which is, what is the most memorable part of your visit at the glaciers?
I would say for sure. I have a good memory and a bad memory.
Both.
I'd say for sure just how beautiful it is. You know, I show these pictures and I talk about it. And there's these great videos that unfortunately aren't mine because I'm not a great videographer. But it's so strikingly beautiful. And when I talk about it, I get passionate because, you know, in these pictures, you see just white and brown. But when the sun is moving in the sky and the glacier is picking up all these different shades of blue, for example, and you can see maybe different melt events or ice that's then ablated up or, you know, been transported. And it's so beautiful how much the environment changes just by the sun moving around in the sky. And then in terms of like worst, like most memorable on a bad side, it's cold. Like I'm definitely a cold weather person despite being Dominican. Um, but there are some days where it was just miserable. And you probably saw in some like in one of my pictures, the one where I talk about the view, I'm wearing just a sweater and a hat, and it was warm and sunny and beautiful. And then there's a picture I showed before that where I have two scarves wrapped around my face and I'm wearing this huge parka. And like there was definitely one day at Schroeder Hill, so that's actually closer to the pole, that all of us were like telling the helicopter pilots, just take us out. It's so cold.
Just, just take me home.
Yeah, we had finished, and normally we might like take some pictures just to remember things. We were just like, please take us home.
Oh,
It's so cold here.
that's another question that came up for us was, so how do you stay warm when you sleep? Like your home is a tent. I mean, that tent can't be, super warm or anything like that. How do you stay warm?
Yeah, so the tents are actually super warm. They're called Arctic oven tents, which you'd assume that they have an oven in them. They don't. They're just plain tents. But whoever made this needs to win some award because they do a really good job of collecting heat throughout the day. So it was a little bit harder in Greenland when it was negative 40, 50. But at Shackleton, you know, every night I had to roll up my tent and vent it out. I'm also like a very warm person. So the tents are great. And you have a sleeping bag, you sleep with a hat on and usually with, you know, maybe a base layer. So like long underwear or whatever to wear to sleep. And it's not that bad. The sun never sets, so it's just constantly beating on it. So like think about your car, right? Your car itself isn't necessarily warm, but when it's sitting out in the sun, like getting beat all summer long, like it gets pretty toasty in there. And that's just like the tents.
Um, Selena Taylor wants to know, how do you keep food fresh in the freezing climate? So like, what do you do for food there as well?
Fresh food, that's funny. So we really don't have fresh food. McMurdo, that big US base, they get shipments in, but at Shackleton, everything's frozen. And maybe if a plane comes in to resupply, they might bring us like oranges, which is the best day ever to have like a fresh orange. We actually keep most of our food outside. So outside that long or yellow tube, out back there's a little tunnel, and it's an underground storage. So we just dig a hole and put our food there. When we're going out in the field, we take sandwiches or leftovers from whatever we ate the day before. Obviously, there's no microwave, so sandwiches are usually better. Um, and we don't really worry about them out in the field.
Yeah, I mean, it sounds like you're just in a permanent freezer, so you're
Yeah,
not so
but
worried
it,
about
yeah,
microwaves or anything.
we're not super concerned.
That's great. We have a question from a student at Brown Elementary School that wants to know, what month did you visit the glacier, and are there only certain times that you're able to go?
That's a great question. So we were there just before Christmas until January. So we were there like in their summertime. So Scientists are in Antarctica year round, but once the sun sets, it's mainly like astronomers or people who are doing upper atmosphere work who need like the clear skies. There have been a couple of times, I think there are, maybe it's just one where they stayed like a late season where they went when it was still dark in the dry valleys. But in the wintertime, it's really cold and really, really windy, like dangerously windy. So trying to take a helicopter out there is a risk. So most scientists who are either ecologists, biologists, geochemists, like what we do, we're there from, I'd say, November to about February is our season. And again, knowing that there are other scientists that do stay year round and do stay there longer. We had a short trip. It was great.
One question, just about climate change in the area. Have you seen the impacts of climate change, like on Shackleton Glacier, or when you've been down in Antarctica or Greenland firsthand? And someone wants to know if you've actually seen a calving event and what was it like if you did?
Yeah, so I haven't, because I work primarily on soils, I haven't had the opportunity, good or bad, to see a calving event. The season that I was up in Greenland was actually a pretty cold year. The year before, so that was, or a couple years before the summer of 2012, it was a huge melt year in Greenland, and we could actually see that. Normally, you don't have like meltwater at Summit Station, so in the like think South Pole, that's what Summit Station is. And usually you don't have any melt there, regardless of how warm it is. But when we were drilling our ice cores in Greenland, we found that melt layer, which is just crazy to think about, because it never gets that warm there, but it did. And since then, it happens much more frequently. And that melt event that I described at Shackleton, like, yeah, I can't really say exactly what it's from because we haven't really looked that far into it. But if you look at these satellite images from 1960 to 1996, these lakes look pretty much the same. And then between 2006 and when I was there in 2017, 2018, it's actually changed a lot. And we looked at a similar valley and same thing, within like 5 years, this lake that wasn't there before filled up, or pond. It's pretty small. So I haven't seen any calving events, but I have seen some really, really warm days that are outside of our typical range of normal.
And just one like final thought question. We've got a bunch of young people with us, this afternoon, and some of them might be interested in some, action they can take, or, some advice for young people on what to do if they're worried about climate change or they want to get involved in studying earth science or, our climate in any way. So do you have any advice or actions or any, words of wisdom to pass down?
Yeah, I mean, you hear all the time, right? The kids are our future. I think the first step is just to care. The Lorax said it really well. We need people to just care a lot. So if you're interested in climate change, there's a lot of really great websites. There's climatechange.org. I know NOVA has a ton on their website, to just start thinking about really how you are a person on this planet and how you can live on this planet without necessarily, I don't want to say destroying because that sounds really harsh, but how you can live with a minimal impact or a diminished impact. So if you are more interested on the science side, I'd say get involved. Not everybody has geoscience courses in their high schools or their middle schools, but anyone can be an earth scientist. I mean, go outside and just appreciate what you see around you. Start exploring, turn over those rocks and look at them and say, start asking questions. I think that's the biggest one, is ask questions. Whether that's like about yourself and the impact that you have on climate change, or whether that's, just learning about the planet that we live on.
Awesome. Melisa, thank you so much for joining us today, answering all of our questions.
Well, no, thanks to everyone who listened.
Of course. Are there any other resources or links folks can check out to learn more about you or your work, or anything else you want to share with us?
Yeah, I mean, if you're interested, there's that bird.osu.edu page. And then I put my email in the first slide, but it's Diaz, my last name, .237@osu.edu. So the bird page has a lot of really fun stuff. And I'm really passionate about education and outreach, and there's really, really cool demos on there. So I'd say check it out.
Awesome. Absolutely. And, color in your picture page, because
Oh yeah.
that's so cool.
If
Just
you
a colored page.
if you email it back to Bird, they'll like share it on their social media too.
Ooh, so cool. So I also want to give a big thank you to all of you for joining us, for asking your questions. This series wouldn't have been possible without your excitement and your engagement. So thank you very much. If you missed our other 2 field trips, you can check them out on our YouTube channel. They're both there and will live there forever. So go ahead and give them a watch if you've missed them. And if you're looking for more information about NOVA's Polar Extremes project, which is what brought us these 3 virtual field trips, you can visit the Polar Extremes collection on PBS Learning Media. You can play the NOVA Polar Lab, or you can watch the 2-hour show on NOVA's website, pbs.org/polar extremes. And also, if there are any subjects that you're interested in learning more about, let us know in the comments. I mean, we will be here for you as long as we are all sheltering in place and being safe. So we will definitely be hosting more virtual field trips in the future. And we want to hear from you about what you want to see. So let us know and we can try and make that happen. So thank you again. Stay safe, stay well, and we will hopefully see you soon. Take care. Thanks again.